Hi students, welcome to Roots Academy. Myself, Inayatullah, lecturer of mathematics. Student, in our last video, we discussed the problems based on logarithmic function as well as an exponential function. And student, in today's video, we will start the problems based on parametric functions, which are very important. So let us start today's topic, that is parametric functions under differentiation chapter. Parametric functions. What exactly a parametric function is? Any two functions depends on a single parameter or single variable, then those functions are called as parametric functions. In general, suppose if I have a function x is my function and it is in terms of t, so x is equals to f of t, and I have another function y, this is equals to g of t. So we can see here x and y are two different functions, but both the functions has same independent variable, that is t. Both the functions are depends on t. So these two functions are called as parametric functions, where t is the parameter. Here these two functions combined together are called as parametric functions, and t is a parameter. Because t is the only independent variable in these two functions. So whenever we can see these kind of functions, then those functions will declare it as parametric functions, and not necessary that it should be t always. Sometimes we'll take t is a time parameter, time variable is t. Then some other time we will take theta. If it is a trigonometric function, in general we'll take theta. So whatever a two functions depends, that particular variable is called as parameter. Let us see the problems of parametric functions. Simple problem here. The first, So before I go to the problems, let me see how can we get the derivative of these two functions. How can we get the derivative of parametric function? Students, here, x is dependent on t, so we can differentiate x with respect to t. We can differentiate x with respect to t, because t is the only independent variable here. So is equals to f dash of t. The next here, y is dependent on t, so we can differentiate y with respect to t. Y is also differentiating with respect to time variable t. This is equals to g dash of t. But we should find dy by dx. So to find dy by dx, what exactly we'll do here is we will differentiate, we'll divide this with this by this. We'll divide dy by dt divided by dx by dt. So in parametric functions, our dy by dx will be equals to dy by dt whole divided by dx by dt. This is the formula we will use to find dy by dx in parametric functions. So dy by dx is equals to dy by dt divided by dx by dt. If time is the variable. If theta comes, then obviously it is dy by d theta divided by dx by d theta. So student, I hope you understood the definition of parametric functions as well as the concepts. Now let us start the problems of parametric functions. And student, problem based on this parametric functions is very important. For 3 marks, they will ask one problem related to this topic, parametric functions. Parametric functions. Okay, since let us start the problems. First one is if x is equals to 2at square and y is equals to a t cube, y is equals to a t cube, find dy by dx. Straight here, x and y are two different functions which are dependent on t variable. So in this problem, we can call it as t is a parameter, and here this dy by dx, instead of dy by dx, in your examination you can ask the question, find the derivative of this function 2at square as well as with respect to at cube, or find the derivative of at cube with respect to 2at square. In this way also you can ask the questions. That is, find the derivative of one function you will give without mentioning x, y or anything with respect to other function. That is also we can consider that parametric functions. So that also will differentiate like this only. We will consider first it is a parametric, then we will follow the process of parametric function derivatives. Its solution will be so first given x is equals to 2at square. This is the function, and y is equals to at cube. First, let me differentiate x with respect to t. Differentiate x with respect to t. So dx by dt is equals to 2 is a coefficient as well as a is a coefficient, as it is derivative of t square is what? 2t. So this becomes 4at is the derivative of dx by dt. Then let us differentiate y also with respect to t. So differentiate y with respect to t. What do we get? We get dy by dt is equals to a is the coefficient, as it is derivative of t cube is 3t square. So finally this will be 3at square. 3at square. So how do we get dy by dx here? We get dy by dx, or instead of dy by dx we can also call it as derivative of this function, that is at cube, with respect to 2at square. That is dy by dx here, because this is y function and this is x function. So I am again telling that it is always not necessary that two functions should be specified, x is equals to and y is equals to. You can ask the question like, find the derivative of at cube with respect to 2at square. If they mention this kind of question, also you should consider it is a parametric function. That time you should give the name which is x and which is y. With respect to that, you should differentiate. So in this case, our dy by dx will be dy by dt whole divided by dx by dt. This is equals to, what is our dy by dt? It is 3at square divided by dx by dt is 4at. Now a and a gets cancel here. T one time and one time gets cancelled here. The left out is 3t divided by 4 is the final answer. Numerator have 3t divided by 4 in the denominator. So since this is the exact procedure we will follow to find dy by dx in parametric functions. Now students, let us go to the next problem. Find dy by dx if x is equals to sin t and y is equal to cos 2t. Has given again two functions. One is x, is sin t, another is y, it is cos 2t. In this two functions, t is the parameter. So let us start differentiating this one by one. Given x is equals to sin t and y equals to cos 2t. What is the derivative of sin? We know it is cos. So dx by dt. Okay, first I'll write differentiate x with respect to t. It is dx by dt is equals to derivative of sin is cos t. Very simple derivative. Next, on the other side, we have y is equals to cos 2t. So we should write differentiate y with respect to t. So what do I get? Dy by dt is equals to, here it is multiple angles, cos 2t. Derivative of cos 2t is minus 2 sin 2t. The answer. So dy by dx here is dy by dx is equals to dy by dt whole divided by dx by dt. So here our dy by dt is minus 2 sin 2t. Minus 2 sin 2t divided by dx by dt is here. It is just cos t. Now still we can just stop here, but if we stop here we will not get full marks. The reason is we can easily simplify this. There are formulas for this, so we must apply the formula. If we stop here itself, it's okay, derivative is completed, process is completed, but we will not get full marks. The reason is this too can be further simplified. So in mathematics, not only in this topic, in mathematics generally, whenever the simplification is possible, we must simplify the steps. If not, definitely we will lose our marks. So let us simplify this. If at all we are trying to simplify, we should use its formulae because it is trigonometric. Yes, in our first PUC trigonometry, we studied the formulas of sine 2 theta. It has two formulas. I will prefer first one here. So I'll write the formula here. Sine 2t is equals to 2 sine t and cos t. This is the formula of sine 2t. It has another formula also, but that is not required right now. So dy by dx is equals to minus 2 as it is, just for sine 2t, and write its formula. So its formula says that 2 sine t into cos t divided by cos t. Now cos t and cos t gets cancelled, and at the end the final answer is minus 2 into 2, it is 4 sine t. This is the final answer. Okay, students, now let us go to the next problem. If x is equals to cos theta minus cos 2 theta and y is equals to sin theta minus sin 2 theta, find dy by dx. Solution: given x is equals to cos theta minus cos 2 theta and y is equals to sin theta minus sin 2 theta. So here the two functions depends on the parameter theta. So theta is a parameter here. So we should differentiate both the functions with respect to theta. So let us differentiate one by one. So first I will differentiate x. Differentiate x with respect to theta. So in both the functions we have two terms. First is cos theta and another is cos 2 theta. Dx by d theta is equals to derivative of cos is minus sin theta. We have minus cos 2 theta here, so minus as it is. Derivative of cos 2 theta is minus into minus, it is plus, because derivative of cos is negative. Already one negative exists here, so two negatives comes means it is considered as positive. So that's the reason I wrote plus here. So it is 2 sin 2 theta. Now here I can easily simplify this itself. So minus sin theta plus 2 sin 2 theta formula. This sin 2 theta formula, 2 sin theta into cos theta. So here I can easily take sin theta common. If I remove sin theta, then the left out part is minus 1 here plus 4 cos theta. This is my dx by d theta. Now let us try to find what is its derivative now. That is derivative of y with respect to theta. We'll write differentiate y with respect to theta. Can you get? dy by d theta is equals to derivative of sin is cos theta minus as it is derivative of sin 2 theta is 2 cos 2 theta. 2 cos 2 theta is the derivative of sin 2 theta. Now here, if you apply any formula, we cannot take anything common here. Cos 2 theta is 2 cos square theta minus 1. So we cannot, okay. This can be written as, okay, cos theta as it is minus cos 2 as it is, cos 2 theta formula. Cos 2 theta has 4 formulas. Let me use the second one, and that says that 2 cos square theta minus 1. Now with this, if I multiply this, I will get cos theta minus 2 to the 4 cos square theta minus into minus is plus 2. So here I can easily take cos common. If I am removing cos here, I can write 1 minus 4 cos theta plus 2. So my dy by d theta will be cos theta into 1 minus 4 cos theta plus 2. Now with these two derivatives, I should find dy by dx. Let me write here. So my dy by dx is equals to dy by dx is equals to dy by d theta all divided by dx by d theta. And the next is this is equals to dy by d theta is cos theta bracket 1 minus 4 cos theta plus 2 all divided by dx by d theta is sin theta minus 1 plus 4 cos theta. Here there is a plus 2 here in the numerator, and so numerator and denominator we cannot cancel any terms because nothing is there. Now let us start the next problem. If x is equals to a into theta minus sin theta and y is equals to a into 1 plus cos theta, find dy by dx. Here again, two functions are given with theta is a parameter because both the functions depends on theta. So let us try to differentiate this. Given x is equals to a into bracket theta minus sin theta and y is equals to a bracket 1 plus cos theta. First, let us differentiate x function with respect to theta. Differentiate x with respect to theta. So what do I get? I'll get dx by d theta is equals to a into derivative of theta with respect to theta. We know it is 1 minus as it is. Derivative of sin theta is cos theta. Next, y with respect to theta. Differentiate y with respect to theta. This can be written as dy by d theta is equals to a is a coefficient as it is. Derivative of 1 with respect to theta, it is 0. It is 0 plus derivative of cos theta is minus sin theta. So plus into minus is minus sin theta. And finally, I can write this as minus a sin theta. These are the derivatives of two given function. Now let us try to find dy by dx. Dy by dx is equals to dy by d theta all divided by dx by d theta. So now let us try to substitute the values of dy by d theta and dx by d theta here. So dy by dx is equals to, what is my dy by d theta? It is minus a sin theta all divided by dx by d theta is a bracket 1 minus cos theta. Now a and a get cancelled here. 1 minus cos theta. We have a formula, not direct but indirect formula is there. And sin theta is also we have formula in terms of half angles. So both the formulas in terms of half angles. Student, in the last problem I clearly said that wherever the simplification is possible, we must simplify. Otherwise, we will simply lose our mark. If there is no simplification, like our previous problem, then we no need to simplify, we'll stop there itself. But here, since simplification is possible, so let us simplify. That is equals to minus as it is. Sin theta can also be written as 2 sin theta by 2 into cos theta by 2 divided by 1 minus cos theta. The formula is 2 cos square theta by 2. Sorry, let us see the formula here. I will do the rough work here. Cos 2 theta is equals to 1 minus 2 sine square theta. So it is, sorry, not cos square. So it is 2 sine square theta by 2. So student, according to this formula of cos 2 theta, the value of 1 minus cos theta is 2 sine square theta by 2. Now numerator and denominator, 2 and 2 gets cancelled. 1 times sine theta by 2 in the denominator, 1 times sine theta by 2 in the numerator gets cancelled. So minus as it is, left out in the numerator is cos theta by 2 divided by, in the denominator, sine theta by 2 is left out. So cos by sine, it is cot. So minus cot theta by 2 is our dy by dx. The next problem. If x is equals to sine cube t divided by root of cos 2t, y is equals to cos cube t divided by root of cos 2t, find dy by dx. Find dy by dx. Okay, so here the two functions are dependent on t. So t is a parameter, but in both the functions u by v is like this, that is, it is a rational function. So if you want to differentiate x with respect to t, we must use quotient rule. Same thing for y with respect to t also. So let us start differentiating one by one. Solution. Given x is equals to sine cube t divided by root of cos 2t and y is equals to cos cube t divided by root of cos 2t. Now differentiate x with respect to t. Differentiate x with respect to t. So it is dx by dt is equals to quotient rule. Root cos 2t as it is, denominator. Then derivative of numerator. What is the derivative of this sine cube t? It is 3 sine square t into derivative of sine t. We are using chain rule here. So derivative of sine t is cos t minus sine cube t, derivative of the denominator. In denominator also we are using chain rule. First is a root function, then trigonometry. The derivative of root It is 1 divided by 2 root x into derivative of cos 2t is minus, already one minus exists, this becomes plus into sine 2t and 2 sine 2t. There is a minus, but that minus I involved with this minus, so it becomes plus. Now this 2 and this 2 gets cancelled. Whole divided by square of the denominator. The square and root gets cancelled, which is equals to. Student, here we must use LCM in the numerator because there is a denominator in the second term, and our denominator is root cos 2t. So this itself is the LCM in our numerator. So if I take LCM here, this term is already exists here. So we will get square of this. So root of cos 2t whole square. I will write 3 here. Into sine square t into cos t plus sine 2t into sine cube t divided by root of cos 2t. This is the numerator LCM. Now this is anyhow it is in denominator. This gets multiplied to cos 2t. This cos 2t is in still denominator. Now after this, I can easily cancel this square and this root. Now next, what is there with us? I can take sine square t common. If I am taking sine square t common here, what do I get? 3 cos 2t into cos t plus sine 2t. There is a sine cube t. In this sine square I already removed. These are taken common. So left out is only sine t divided by cos 2t into root cos 2t. So this is the final dx by dt. Further we cannot simplify because here this 3 creates a problem. If there is no 3 here, then we could have used cos x, cos y plus sin x, sin y formula. So because of that, and here we cannot cancel anything, let us consider this is our dx by dt. After this, let us find what is our dy by dt. Now students, let us differentiate y with respect to t. Differentiate y with respect to t. So dy by dt is equals to quotient rule, same as we differentiated x with respect to t. So first denominator cos 2t, derivative of cos cube is 3 cos square t into derivative of cos is minus, I'll write it here, minus sin t minus of cos cube t as it is. Derivative of the denominator, it is in the form of root. So its derivative is 1 divided by 2 root cos 2t into derivative of cos 2t is minus 2 sin 2t, minus into minus is plus, into 2 sin 2t. 2 gets cancelled here. Whole divided by square of the denominator, root of cos 2t whole square. Now square and root gets cancelled. So this is equals to, again we must take LCM here in the numerator because I have denominator. So LCM is root of cos 2t. So if I am taking LCM, already one same term exists here. I will get minus whole square 3 cos square t sin t plus cos cube t into sin 2t divided by root of cos 2t into cos 2t. Now square and root gets cancelled. This is equals to minus. Instead here, cos cube is there here and cos square is there. I have taken sin square common in sin. Like that, here I can take cos square common. Cos square t if I am removing, then I will get 3 cos 2t into sin t plus cos t into sin 2t divided by cos 2t into root of cos 2t. This is our final dy by dt. Now after getting this, we should write what is our dy by dx. Student, here our dy by dx will be dy by dt whole divided by dx by dt. What is my dy by dt? It is already exists here. Minus cos square t into 3 cos 2t into sin t plus cos 2t, cos t it is cos t into sin 2t whole divided by cos 2t into root cos 2t. This is just dy by dt whole divided by dx by dt value. I should substitute here. What is dx by dt? It is sin square t into 3 cos 2t into cos t plus sin 2t into sin t divided by cos 2t into root cos 2t. This is the value of dx by dt and this is the value of dy by dt. So the final dy by dx is, this denominator cancels with this one. Now here cos square by sin square is part square will come. So minus part square into this. Dy by dx is equals to minus cot square t 3 cos 2t into sin t plus cos t into sin 2t divided by this sin square already taken with cos square, then only I got part, or simply I will write inside the bracket elements is 3 cos 2t into cos t plus sin 2t into, and this is the final value of dy by dx. Whose functions are x is equal to sin cube t divided by root of cos 2t and y is equal to cos cube t divided by root of cos 2t. Okay students, now let us go to the next problem. If x is equals to a bracket cos t plus log bracket tan t by 2 bigger bracket and y is equals to a sin t, find dy by dx. And here x is equals to a cos t plus log of tan t by 2 and y is equal to a sin t. A sin t. Y function is very simple. It is just trigonometric sine function. But cos has two terms and in the second term it has chain rule. Totally three functions are there here. First is log, then trigonometric tan, then t by 2. So whenever we are differentiating this, we must use a chain rule. Solution. Given x is equals to a bracket cos t plus log bracket tan t by 2 close the bracket and y is equals to a sin t. Differentiate x with respect to t because t is a parameter here. So dx by dt is equals to a into derivative of cos is minus sin t plus first function is log, derivative of log is 1 divided by tan t by 2 into derivative of tan. Log function is over, derivative of log x is 1 by x. Now derivative of tan is secant square t by 2. The next t by 2 is also a function. Derivative of t with respect to t is 1, so into 1 by 2. So students, this is a complete derivative of dx by dt. Let us write it in proper form. This can also be written as a into minus sin t plus secant square t by 2 divided by 2 tan t by 2. This is our dx by dt. Differentiate y with respect to t. I am differentiating this simple function y with respect to t. So dy by dt is equals to, here is the coefficient as it is, derivative of sin t is cos t. Now what is dy by dx? Dy by dx is equals to dy by dt all divided by dx by dt. So then this can be written as a minus sin t plus secant square t by 2 divided by 2 tan t by 2 whole divided by a cos t. So a and a gets cancel here. So here in this second term can be simplified. We have secant square here, and we know secant square can be written as 1 by cos. 1 by cos. And I have tan here. Tan can be written as sin by cos. A and a gets cancelled. So my dy by dx is equals to minus sin t, no changes in the first term, plus, and there is a changes now, secant square can be written as 1 by cos square t by 2 all divided by 2. Tan can be written as sin t by 2 divided by cos t by 2. Of course, all divided by cos t is exists here. So just if you focus on this particular term, I can cancel this cos t by 2 and this cos t by 2 one time gets cancelled. Now this 2 sin t by 2 will multiply to this, because this is divided with this, isn't it? This will be divided, it is whole divided. So denominator's numerator will multiply with the numerator's denominator. With this 2 sin t by 2 gets multiplied to cos t by 2. Other things are same. So it is minus sin t plus 1 divided by 2 cos t by 2 is left out one time, and it is sin t by 2 whole divided by cos t. Now since the moment I wrote it is in terms of 2 sin and cos with same angle, I can easily consider this is sin t formula. Sin t, this can be written as sin t. Sin t half angles we can write like this. So this will be minus sin t plus 1 divided by sin t whole divided by cos t. Now student, if I take LCM in the numerator, if I am taking LCM in my numerator, minus sin square t plus 1 divided by sin t whole divided by cos t, as we multiplied here. So this denominator's numerator gets multiplied with this. So into cos t is. Now stand here, 1 minus sine square t or minus sine square t plus 1 is cos square t. So numerator can be written as cos square t divided by sine t into cos t. So here one time cos and one time cos in the denominator gets cancelled. So finally I got cos in the numerator and sine in the denominator. So that is cos t by sine t. Finally it is cot t is the answer. So students, for this function, the dy by dx is cot t. Okay, students, now let us go to the next problem. If x is equals to a cos theta plus theta sin theta and y is equals to a sin theta minus theta cos theta, find dy by dx. To find dy by dx. Solution. So x and y both are dependent on theta. So theta is the parameter. So let us directly differentiate x with respect to theta x. So the moment we wrote x is differentiate with respect to theta, here theta and sin theta gets multiplied. So we must use product rule here. First term, no issues, direct differentiation. But whereas in the second term, two functions are multiplied. Function is theta, second is sin theta. So we must use product rule here. That is dx by d theta is equals to, here is the coefficient, derivative of cos is minus sin theta plus first function theta as it is, derivative of sin is cos plus sin theta as it is, derivative of theta with respect to theta, it is 1. Now with this, I have sin theta into 1 is sin theta positive, and I have minus sin theta here. Both gets cancelled. The final dx by d theta is a into theta cos theta. And the next, differentiate y with respect to theta. So here also in y function there are two terms. First term is direct differentiation, but second term we must use product rule because two functions are multiplied here. So dy by d theta is equals to a into derivative of sin is cos theta minus, here minus is for this complete product rule. So we put bracket minus first function as it is, derivative of cos is minus sin theta plus cos theta as it is, derivative of theta is 1. Let us multiply this, a bracket cos theta minus into minus plus theta sin theta, minus into plus is minus cos theta. plus cos theta and minus cos theta gets cancelled, is equals to a theta sin theta. Just here dx by theta is a theta cos theta and dy by d theta is a theta sin theta. Then our final dy by dx, right? dy by d theta divided by dx by d theta. So this is equals to a theta sin theta divided by a theta cos theta, a theta in the numerator and a theta in the denominator gets cancelled. Now sin theta by cos theta is tan theta. Tan theta is our final dy by dx for this functions. Questions? Now let us go to the next problem. If x is equals to square root of a power sin inverse t and y is equals to square root of a power cos inverse t, show that dy by dx is equals to minus y divided by x. And this time he is asking us to prove that the derivative of this function with respect to this function is minus y by x. So let us first differentiate x with respect to t, because t is a parameter. Then we will differentiate y with respect to t. Then we will see what is our dy by dx. So first, given x is equals to square root of a power sin inverse t and y is equals to square root of a power cos inverse t. So here, if we are differentiating x with respect to t, we must use chain rule. And here in chain rule, there are three functions. First is a root, then is a power x, then is inverse trigonometric function. Here inverse trigonometric function is considered as x. Same thing for y also. So totally 3 times we should differentiate continuously, because we are using chain rule here. And here 3 different functions are there. First is root, then a power x, then inverse trigonometric. Differentiate x with respect to t. So it is dx by dt is equals to, first root, the derivative of root is 1 divided by 2 root a power sin inverse t into, next is a power x, a power sin inverse. So that is considered as a power x. Derivative of a power x is a power sin inverse t into log a into derivative of sin inverse t is 1 divided by root of 1 minus t square. So this complete is our dx by dt. Next, directly I will come to y with respect to t. So differentiate y with respect to t. Same process, whatever applied for x, same process should apply for y with respect to t also. Because here also we have three different functions and we are using chain rule here. So continuously 3 times we should differentiate. So dy by dt is equals to derivative of root. Derivative of root is 1 divided by 2 root a cos inverse t into derivative of a power x. A power cos inverse t into log a into cos derivative of cos inverse t. Derivative of cos inverse t is minus 1 divided by root of 1 minus t square. So after getting dx by dt and dy by dt, let us write dy by dx. That is equals to dy by dt all divided by dx by dt. So this is equals to our dy by dt is, there is a minus in the numerator here. So minus a cos inverse t into log a divided by 2 root of a cos inverse t into root of 1 minus t square all divided by a power sin inverse t divided by 2 root of a power, sorry, still I don't have space here. I erase this. Dy by dx is equals to dy by dt value is, numerator is a cos inverse t into log a divided by 2 root of a cos inverse t into root of 1 minus t square all divided by, now dx by dt value is a sin inverse t into log a divided by 2 root a power sin inverse t into root of 1 minus t square. Since there is a minus here, this minus I wrote it first because this minus is multiplied to all the functions, all the 3 terms. Let me erase this answer now. Now student, after this, let us try to cancel wherever cancellation is possible. Log a gets cancelled. Then root of 1 minus t square gets cancelled. This 2 and this 2 gets cancelled. Now what do we have? We have minus a power cos inverse t, root of a power cos inverse t. So student, I will do the rough work here. Whenever we get a situation called x divided by root x, then this is considered as x, and in the denominator I have root x. Then this is my x, then definitely this is root x. So x by root x, we will call it as x can be written as root x whole square divided by root x. X by root x can also be written as root x whole square divided by root x. Now one time root x in the numerator and denominator gets cancelled. The left out part is root x. So finally, the value of x divided by root x is root x. according to that, minus as it is, I can write root of a power cos inverse t combined together, divided by, same thing exists here, but just instead of cos inverse, it is sin inverse. If this is my x, in the denominator I have root x. So this can be written as root of a sin inverse t. Now if I just check this in the question, the value of x is specified that root of a sin inverse t. So wherever I have root of a sin inverse t, then so minus as it is. And wherever I have root of a cos inverse t, I can write y. So this is my y divided by x. So my final dy by dx is equals to minus y by x. So hence it is true. Student, this is about the parametric functions. Student, if you have any doubt in today's topic, you can put your doubt in comment box. And if you are new to our channel, don't forget to subscribe. To help other students, keep sharing our video. Thank you, students.